Okay, so welcome to day 3 of QuickPass. Today is going to be quite full with the lesson we have, which is going to be Python loops, and then we're going to talk about Python functions. Those are two very big subjects, so I'm going to go over things, and it's going to be a lot of information initially. And what I'm going to do is kind of go over the GitHub page that we have, or the markdown file. I'm going to go over all these examples and show how to run each one. We'll go through some examples there, and then so I'm going to show you the loop structure, and then we're going to do some looping with different data types such as strings, lists, tuples, and dictionaries. And then we're going to shift gears and go over Python functions. Functions are a key component of most programming languages, and you can think of functions as of like little programs in themselves. They're meant to do one thing only, and that is to take an input or inputs and then produce an output, or at least give a nothing back, but to do something. And what functions do is it makes code reusable, and that's what you want when you write code. Is you want code to be reusable instead of writing, repeating yourself over and over and over again. And then we'll conclude. And then this afternoon we did add some exercises at the bottom, and hopefully we'll have enough time to go over those exercises at the end. So let me go ahead and start sharing my screen. Share, yes. Okay, can everybody see my screen?
Yes.
Okay, perfect. All right, so again, I kind of discussed what we're going to be going over here. And so really, we can start right here with just the definition. Loops are used to execute a block of code repeatedly. Python offers several types of loops because there's different use cases for each kind. Some of the basic things you need for a loop is some sort of iterable, something that you can iterate over. And there's data types for that. You have lists, you have tuples, you have even the unordered data types like dictionaries that you can loop over, and you can do something repeatedly instead of writing a bunch of code out repeating steps. And so I was going to go ahead and throw this code in here to kind of show you what it does. I do have to fix a little typo. I saw that whenever I loaded it. Okay, so in this first example, we have we're defining a variable called URLs, and with a single equal sign. Again, if you recall, that's the assignment operator. So we're going to take this variable and assign it to a data type. In this case, we have a list, and you can tell it's a list because we have these open and closed brackets on either side. And then you have some data here separated by commas. And so just by looking at this, you can tell, okay, it's a list, and it looks like it's 4 items long, and each one contains a URL. And those URLs, the data type of those are strings. So we have a list of strings in here. And before we get into a loop, what if we wanted to print each one of these out without a loop? How would I print out the first web address there, reddit.com? How would I do that?
Index.
I'm sorry,
you do that?
I didn't hear. What'd you say?
Could you print index or?
Yeah, so I could print an index, right? So I could say, okay, let's go ahead and say URLs at the index of what? What index is that at? So we have a list and we have these indexes, right? What's the first index?
0.
0, that's right. Okay. And then I can do, let me see if I remember to do this. Nope. There we go. Okay, I can do that. And then I can just change these, right? 1.
But if you just want to print Reddit, then you don't even need a loop at all, right?
Right. If you just wanted to access one, then I would just go ahead and I would just do the first one. But I'm just going to go ahead and print them all just so we can see it. And so I'm going to go ahead and pick the kernel. Okay. And there we go. I printed each one of these URLs. Okay. What if this URL listing was 1,000 items long? Then it's unrealistic to type all that code. And that's where loops come in, because we can use a loop to not only like, print something out, which is what we do when we're learning code. We're just printing things out all the time. But you can use it to find a certain URL or to, count them, because sometimes you'll get, when you get into web development and you're relying on a source like from a API, and you're going to get something back from them, you don't know how long it is. You have to have some logic to handle an unknown length, a list of unknown length, or some JSON object that's really gigantic, and you have to parse through it. That's where the power of loops come in. So yes, we could print them all by doing that, or we could just do this. And this is much shorter, it's much cleaner, much easier to read. And there's a lot going on here that we can explain. So first off, we have these letters or these words that kind of show up in red. Those are the reserved words in Python where, they have a special function. And then we have this, we're saying URL, and then we're saying in URLs. Well, that's the same thing as, if you want to take a look at this, open this real quick. There we go. Okay. You have a collection, right? A collection of something, this type, my items in the collection. And then here we're saying for individual item in my collection, we want to do something. So in this case, we want to, we're going to take each one and we're going to make what's called a temporary variable. And so URL becomes a temporary variable. This right here is the traditional way we assign a variable. Inside of a for loop, we kind of assign a variable on the fly as the loop runs. And then the collection is URLs. So it's this right here. So this is put right here. And then we're saying, okay, now I want to print this temporary variable every time it runs. And in this case, I'm going to run this, until it exhausts itself. So all the way to the end. So I want to do that. So if I ran this, I get the same exact result. Nothing changed. You didn't see a result. I can
Hey, Aaron, quick question.
yeah.
When you said until it exhausts itself, you mean until it reaches the end of the list, correct? Which would, in this case would be Amazon. And once it reaches Amazon, it has exhausted itself, so it can no longer run the loop.
Right, and it stops. Yeah, and it will stop at that point. Yep.
Oh, okay, perfect. Thank you.
Yeah. And so that's what this is here. It's saying, hey, this loops through the elements of a list or any interval, and you just want to do the same operation for each item. So you're like, hey, I don't have any different function I'm doing for a specific item. I'm just running the same search. And you can do all sorts of stuff. You don't have to print something. You can then put an if statement under here. And you could have it, if you're looking for a certain URL, you can say if URL equals this one URL, you can return, a statement saying found it, it's in here or something, right? I could do that. So that's the first type. It's for I and X. So for element and interval. That's the most common type of loop you're going to see, but you're going to see these others as well. Oh, I was asked to make the font bigger. I'm sorry. Let me go ahead and do that. So yes, this word could be anything. You don't have to use the word URL, but you want to make it descriptive so people understand what you're iterating over. So, I could make that, I could for chicken and URLs print chicken, and it will print the same stuff. we'll just define the word, the term chicken to the URL. So let me see if I can make this a little bigger.
So with that, Aaron, like, so what is after for, like, what is that pulling the URL then? Is that, where does it, like, what is it reading? What is the for reading in that sentence? If you can change it to chicken or whatever word, whatever word you want, like, what is it pulling from then?
I think it's only useful if you reference it later. So when you reference it, we say print URL, that's the connection. So that could be like for I, could be for yada yada. Then you'd have to say print yada yada after that. You'd have to use the same when you later reference.
Yeah, this will tell Python that I want to loop through the entire thing and I want to, go over each item basically. I could do something that doesn't even use this. I could just have it print the same word over and over again and not even deal with this temporary variable. The IDE will probably, put a squiggly line under it and say, this is not being used, but you could do that if you want to. So yeah, but just remember that what you're doing when you're writing the syntax here, this is a temporary variable that you're going to assign to each item as it iterates over. So it's going to loop through, and then, so the first time URL equals reddit.com, then it finishes, it prints it, goes to the next one. Now URL is nike.com, and then it prints it. Then it goes to the next one, all the way through. Okay. So it's just a syntax thing. It's not any more complicated than that. So
Gotcha. Thank you.
Yep. The next type of loop, and is this text big enough, or do I need to make it bigger? And Tim asked, could you use temp variables? You could, but remember with Python, you want it to be human readable. I don't know what X is. I would rather it be more descriptive. So you want to make sure you come up with descriptive terms whenever you're writing code, making variable names. So this next loop type is for I in range, and this one here, what this does is it creates an iterable behind the scenes based on what parameters you put into the range function. So you could say that really we're looping over this, the output of this range function. And I can illustrate this here. So for, and we can do, let's do for I in range. And right now, we'll just keep it simple. Print. So again, we have this for loop. So this is the keyword to say, hey, I'm gonna do some looping. So it's gonna be a loop, and it's gonna be a for loop. And when we use range, what range is doing, and I can actually, I think, highlight over it and see, it returns an object that produces a sequence of integers from start to stop. And if you notice, it says start inclusive and stop exclusive by step. What that means is it's going to give me a sequence from 0, because it's going to default to 0, and then it's gonna go up to 10, but not include it. So it's really going to be 0 to 9 is really what it's going to be iterating over. And that's okay, because I still have 10 items. It's just their index is going to be 0. It's going to start with 0 and go up to 9. So that 10 is not inclusive. And there's other arguments as well. So with range, you can customize it if you really need to. Most of the time when I've used this before, I've just put in, I put in the only mandatory one, which is the stop index, which when you put just one in there, it's going to be the stop index. But if I wanted to count from the number 5 to the number 10, and I wanted to do every single number, I could do this. So what this would do will give me, remember the first one is the start, the next one is the stop, and then the third one, which is also optional, is the step, which means how many it's going to go over. So in this case, I'm going to say for I in range, I want to start at 5 and I want to go up to 10. So I would need to do 11 because it's up to, but not including 11. So that would give me 5, 6, 7, 8, 9, 10. If I wanted to count to, let's do 40, but I wanted to do every, and let's go ahead and let's start at 0. And I wanted to do every even number, I can do a step. And if I run that, 0, 2, 4, 6, 8, 10. So it'll make that iterable for me, and then I just need to print it. And so this is pretty powerful. It's expansive. I really wouldn't worry about the start or the stop and the step right now, but just know that's available. And again, if you're using an IDE, or you can just Google Python range and just put this in there in your Google search bar, you'll find all the stuff you can do with it. So here it tells me I have the start, stop, and step. But here, if I just do simply 10 and I run that, I get 0 through 9.
And I'm guessing it obviously will take float numbers too.
Or is
there, it'll take.
I don't think so. I think it has to be integers, but I have no idea, actually. I've never tried to use a float. No, so it can't. So it says float object can be interpreted as an integer. So there we go. We can't do that. It has to be an integer. So whole numbers, because we're doing iterations. That was a good question. Let's get rid of that error. There we go. That's later. Any questions on the range function? And there's a lot more powerful stuff you can do with that. You can use it to, you can actually put a list that you have before in there, and then you can access, the index of the list using the range. But we also have this other one, enumerate, as well, which will, gives you the index as well. Any questions on these first two loop types? For, yes, it's specifically for loops. It's kind of a Python keyword for loops. Cool. Let me see if I can add a cell. There we go. That'll work. Let's go ahead and just copy this one. Back to the fruits. We have lots of fruit examples. I think it's a rite of passage to have all your examples be some sort of collection of fruit. So in this case, we have our 3 fruits: bananas, apples, and cherries. And now we're doing this different, weird looking one. It still says the 4. So we have that keyword in here. And we also have the in right here. But now we're doing like two variables. And then we're running this keyword here, this function called enumerate, this method enumerate, and then we're going to be going over our collection. So our collection is fruits, just like in our for loop. It looks, it looks, the original for loop looks just like it, just has a separate variable. And now we're printing an F string, and then we're putting these variables in here so we can see what index they're at, and then the fruit name. So if I run this, here's what we get. So we get index, and then with F strings, which we haven't really talked about F strings yet, we did briefly go over in the first lesson. They allow you to kind of directly inject variable names into your string. It's much easier than the older Pythonic ways, which you'll see if you start working as a developer. You'll see some old code with the other ways. This is much cleaner, in my opinion, and much easier to read. But we're printing the F string, and then we're putting the index. So the first time this runs, it's going to grab bananas, and it's going to create this iterable. Index is going to be 0. So just like in the range, it's going to start at 0. And it's going to assign bananas, a string bananas, to fruit. And then it's going to execute that however long the list is. So it's going to go until the end of the list.
Hey, Aaron, real quick,
Yeah.
for that printf index, it's essentially just appending or using, it's kind of like using the appending function, and it's inputting the word index before the numbers, right?
Right. So it's not appending. Appending is adding something to a list. But what this is doing is
Oh, gotcha.
basically it's just injecting the
The
index
word
each
index.
iteration. It's not the word index. It's going to be whatever index equals. So in this case, the first time the loop runs, index equals 0, fruit equals bananas. So then it's gonna go through into this code here, and it's gonna be okay. Well, index, and then the variable index is gonna be 0, so it prints the 0, and then fruit is bananas.
Oh, okay. Got it.
Cool. In fact, I have to help you see it a little better. I use this site all the time when I was learning Python. I don't know if anybody's seen this yet. Let's go ahead and put that. Cool. All right. Don't you love these ads? What is going on here? So what this does, this kind of gives you, and you can do this in an IDE, but I just find it easier to paste it in here. This will allow you to visualize how things are working in Python step by step. So every step the code takes is going to show you the iteration. So the first one that just executed, it created a fruits variable and then gives you your list. And then here it's creating the loop, and it's showing that index is equal to 0, and it's printing index 0 bananas, and then it's just looping through it, and you can kind of see every step. So it's really nice if you're getting a weird result, you can go and find exactly where that result is. Really good at this stage when you're just learning how to do these simple scripts, because they won't be that long. And if you see that it's like hundreds of steps, then you probably made a mistake, and you can figure out where it is. Or if it gets an error, it'll go to an error and then give you the error, what's going on. So it's a really cool website. This one, it's called pythontutor.com, but you can do other code. You do JavaScript as well, C++, Java. So it allows some other languages as well. So
that that F that you have in front of the index on the third line is that's a global function in Python?
No, this is a type of string. So
Okay.
all that is, it's not a function, it's just a type of string. And so the F before the quote, it'll flag it as looking weird. Well, that just tells Python that now I have a string that I can inject variables into.
Gotcha.
Yeah. And then we do have our TAs in the room as well, and you'll see them helping answer questions, and they're also putting some additional info in there. So
So after you use the function enumerate, is it required to use the F?
No, not at all. Nope. I could totally do it this way. So I could do.
So what does enumerate do then? That just loops everything in.
Enumerate gives you. Enumerate will give you the index and the item that you're looping over. So basically it just gives you both of the things. The first loop we did right here, I can't access the index of that URL. It's just giving me this. So I have, like, if there were hundreds of these and I'm looking through them, like, I wouldn't know which one is the index. So enumerate,
so it would, yeah.
Enumerate gives you an index to look at it.
Okay.
So yeah.
And then I'm sorry, you've explained the f function, so I'm a little bit confused what the f function provides then.
Well, it's
Sorry.
not, so it's an F string. It's not a
F string.
function. Yeah, it's just what it does. It's just a type of string. So it has to be typed like this. And allows you to then grab variables that you've identified before. So if you watch this, I can do this is the roots list. And then I can do my curly braces. I can do that. And then it's going to print this whole list, like however many items you have. So if I ran this, it's just going to print it all over and over again, because I'm accessing fruits, not the fruit. I'm actually grabbing the whole list over and over and over again. So this really isn't useful. It's kind of silly code to do, but this kind of illustrates the power of an F string, that I can access any variable in my code and just throw it in here, and it'll automatically cast it to a, it'll automatically cast it into the string so I can see it. So that's all it is. It's just a way of visualizing variables quickly without having to do the old format method.
Gotcha.
So cool. Let's move on. We're gonna go over a special type of loop so we can go over dictionaries. Because dictionaries, remember, we have and I just briefly talked about these, but we have lists, we have tuples, strings. Even those are ordered, they're ordered collections, so they have a certain order and they keep that order until you change it. But you can change it in place. I can change a list in place by using the append function to add an item to the list without redefining it. Tuples, I can't add an item to the list. I have to redefine it, but it still maintains the same order. And then sets and dictionaries, though, they don't have a certain order. They actually, they don't have an order, because when I want to access a certain item in a list, I use the key. Each key in a dictionary has to be unique, and that helps me find all the data in a dictionary. So let's go down to that example here, and we can pull it up in here and watch it work. And so with dictionaries, though, we have the way we write the loop is a little differently. And I was going to explain not only that, but kind of what you typically see when you're looking at code in the wild. When you're Googling like looping over dictionary, you're going to see something a bit different than this. But there's a couple things I need to explain. First off, there's these methods you have to use for a dictionary to loop over them. You can't just loop over the dictionary itself. You can, but you're just going to get the keys back. You're not going to get the values. So you could say for item in dictionary, print item, and it's just going to print the key. So it's going to default to only printing the key. But if you use this items function, when you loop over a key, what you're doing when using items, you're getting the key and the value. So much like enumerate, you're getting the index in the item. For when using this dictionary.items method, what it's going to do is going to give you a key and the corresponding value, and it gives you an iterable. So it's not, so a list type object is not a list. It's still an object, but you can then loop over it using that. And I wouldn't worry too much about what's happening behind the scenes there when I say list type object. Just know that when you do use the dot items, you're able to then loop over it and grab everything. So in this example, I actually have it right here. So I have the variable phones, and we use a single equal sign to assign it. And we know this is a dictionary looking at this data type because it has this curly brace, and then it also has colons inside of it. So that will tell me I have a dictionary. And we can kind of read this. It only has 3 items, but it has this key Francisco, this key Alex, and this key Allison. And then it's a corresponding phone number for each one. Okay. And then here with the for loop right here, we have this keyword for, and we have the N as well. And we're saying, okay, for name and number, so we're assigning two temporary variables called name and number, and we're saying phones.items. So we're using, phones because phones is a dictionary. The dot items is our method to get that list type object that we can loop over. And we want to print, and we're using this F string again. We're going to inject name into there, and then the number as well into a sentence, so it's easily human readable. And if I run this, it says, okay, well, Francisco's phone number is this, Alex's phone number is this, and Allison's phone number is this. Nice, human readable. Typically, you're not going to see name and number. So this is kind of one of those special cases where you're going to see more one-letter things in there. And the reason is because it still tells you what type of data you're looping over. Typically, you're going to see that. And can anybody tell me what K and V stand for?
Key and value.
Yep. Tom put it in the chat. So key and value. You will see this mostly in the wild. Most of the time, people put 4KV in whatever dictionary items. That's just how it is. But you don't have to. You can define another way. I've actually written code that was, I needed to be a little more descriptive than key value. So I actually wrote, variable names in there. But you can do this, and it's going to run the same because I'm still using the same variables in the same spot, just different names. So, but I did also want to show, I'm going to go ahead and grab this one here. Let's see. And then for item in phones. Okay. All right, here I'm saying for item in phones, or for, let's leave item because I know I'm not going to get a phone number. I'm going to get the key. So I'm going to get only the key. If I loop over a dictionary, I'm only going to get keys. I'm not going to get any values. And really, I have no way of doing it unless I did it this way to get the values. Now I could do for item and phones.values like that. And now I can get the numbers, but I don't get any keys. So when you do a standard loop on a dictionary, it'll default to keys, but you could put them in there like that. And this will give you the same result. It'll give you the keys, but you don't have to do that because Python will just default to giving you the keys when you loop over a dictionary, unless you do it this way with the key value. So it's really important you kind of remember this because you will be looping over dictionaries, and just kind of keep this in mind for the exercises and for future use. This is kind of how you're going to do it. So, and this text explains it pretty well what we're doing with these examples. Any questions on the loop types, at least with for loops?
Like I'm always jumping ahead of somebody. Sorry if I'm in the loop. I'm trying to figure out how to ask the question. So the for item is gonna pull the key. But if it's not a dictionary, I guess it just pulls, like in the example before, like for index in the fruit. So for index, that's
Right here?
yeah.
Mm-hmm.
Okay, I guess I don't even know my real question. I'm sorry, Aaron. Sorry about
No,
that. I'm just trying to make sense of it. Sorry.
It's fine. Yeah. I mean, really, sometimes, I'm guilty of having a bunch of like non-questions. I know I have a question. I just don't know how to word it. That's fine. Really, the solution to that is lots of exposure and just really practicing. And I think the exercises we have are pretty good to help you with that. But just remember that this case here, we're using enumerate, because we're trying to get the index and the item to use later on. We're going to do more you're going to do more complicated stuff than just this. Okay, so right now we're just printing. I'm just showing you an example of how the loop works. There's a lot of stuff you can do with the loop once you know how to, once you're comfortable with actually the syntax. And then when you start adding functions inside of a loop to run, functions over and over again, and doing other things, it'll start to click and make sense. So right now, this is all the basic foundation. You're gonna have to do a little bit of like, okay, I don't quite understand the meaning of that, but I trust that it works, and just getting used to it, and I promise it'll get easier. So just know, like, we're really giving you the very basic foundation right now, just so you can, get to these exercises through the application and then the live coding exercise. So awesome. This is a really cool, like, we have a little section here called when to choose. And so this kind of helps you see when you want to, use the certain type of for loop. Of course, with dictionaries, the for key value and dictionary items when working key value pairs. We need to access both elements and their indices with an interval is the enumerate. That one's pretty common. And then, of course, when you need to do a certain number of iterations, you'll want to do for I in range. So, I like to, in my previous class that I taught, near the end, I would make like a Powerball simulator. And so I would code it out, and then I would have it run like 5 million times. So I'd use like for I in range, and I'd put like 5 million. And I would have this drawing go 5 million times and show how many times it takes, how many times I'd run that program for you to finally hit the jackpot. And it was crazy. But you can use that range. I use that as my main driver loop for everything, for kind of showing how the script worked. So that's a good use case for that. And then, of course, the first example we had for I and X, we just want to iterate through the elements of a collection. So this is going to be like your usual go-to loop. But then if you need a little extra, functionality, if you want to grab the indexes or anything else, you can use the enumerate, and so on and so forth. So let's go ahead and talk about the while loop. I can probably get through this, and then we'll take a quick break. But the while loop will run continuously as long as the condition you're evaluating is true. And so there's a bit of danger with that sometimes, because you can have an infinite loop, and so you'll kind of freeze your kernel. You'll have to restart it. But let me go ahead and add some cells here. There we go. So in this text here, we're saying while. So this while shows up as red. I think it shows up as a different color. I can move it over here to my Jupyter notebook. It shows up as red as well there. So it's that reserved word while, and then you're making a condition. And you can make the condition a simple Boolean. I'm not going to run this, but basically I can say while true, and then I want to run some code underneath it. And so I can say, print my name, and it's just going to run and run and run and never stop because it's true. When you get an infinite loop like that running, you can like while it's running, you'll with a Jupyter notebook, it'll like give you a little star and doesn't do anything, but then you'll hear your fan kick on in your computer as it's running. And that's usually how you have if you're running a simple script, that you have an infinite loop going on. In a terminal, you can stop it. You can stop it here in Jupyter Notebook as well. But with a while loop, again, this keyword is while, you have a condition here. Typically, you want it to be a Boolean expression. We learned all about Boolean expressions last lesson, how to make something equal true, how to make it equal false. So we can use a while loop then to do like counting or waiting for a certain condition to happen. So let me go ahead and throw this code in here. So in this case, we are defining a variable called count, and we know we're defining a variable because we have a single equal sign here. So count is our variable, and we're saying it's going to be start at 0. And then we start a while loop, and the while loop, the while turns red, and we're saying, okay, we're going to reference our variable that before this starts to run already equals 0. We're saying while the count is less than 5, I want to print count. And then I want to do this thing where I do a count plus equals 1. So really I want to increment count by 1 up. So I do that, it ends, it's going to go back up to here, right? And it's going to go evaluate this condition again. And it says while count is less than 5, well, now that it ran once, count is equal to 1, it's less than 5, it's going to go do it again. It's going to keep doing it until this right here, this statement evaluates to false. Once it evaluates to false, the loop will stop. And so double check your sign here. If you put it backwards, you won't, in this case, you put it backwards, it won't run at all because count won't be greater than 5. You got to make sure you're just doing whatever you're doing inside the logic of the loop too. You want to make sure you're causing it to eventually end because you don't want this running forever. So in this case, we're going to run it, and it ran all the way up till it got to 4. It incremented it to 5, checked to see if it was equal or less than 5, and it was, and it did not execute again. So it stopped at 4. Any questions with the while loop?
Quick question, Aaron.
Yeah.
So for the while loops, there's no like exact, I guess, function or method to tell it to stop. We just have to tell it to stop, like count plus equals 1, or count is less than 5. We actually have to tell it to stop. There's no like reserved word that'll tell the while loop to stop.
Well, there is. I mean, if this evaluates to false, the loop will stop. But if you never evaluate to false, which you can do pretty easily with you put the wrong type of logic, you miss a sign or something, you don't do something right, you can make it run infinitely, and you'll have to do you'll have to actually stop it manually. With Jupyter Notebooks, you have to stop the kernel and then restart it. I know if you have it running in a console, you'd have to hit like Control-C to stop it. You have to interrupt the process. And so it's not like super dangerous or anything, just you gotta stop it. Otherwise it'll just keep running. So, but you can use a while loop to kind of do the same thing as a for loop in like if you can like measure the length of it, and then you can make a count. You can say if your count is less than the length of the list, keep iterating over it. You can do that, but you can also do something else. You can also like measure another list, and if you're trying to find certain items or a certain number of items, you can like loop over a list and then find one of the items, put it into your new list, and then keep evaluating your new list until like your count's over like 2 or something, and then you'll stop the loop. So you'll stop searching in that other array. I can show you an example of that later, but there's a lot of flexibility with while loops. It's just they can be a bit dangerous because you can get yourself into an infinite loop. So
Gotcha.
Yeah, there's something to think about. Cool. This next section here, really, I kind of explained up here, we're going to be looping over different data structures, whether it be a dictionary, whether it be a string or a list or a tuple. Strings, remember, like I mentioned before, strings are a collection of characters. So they behave just like lists, except they're immutable. They're immutable like tuples are. So once you define a string, you can't inject a character into index 3 of a string, for example. You'd have to redefine the string completely, but you still can loop over it. So in this case here, we have our classic text hello world. I put that in here, and I run that. I'm saying I'm defining a temporary variable. So I have my text defined as hello world, my for loop, my temporary variable, and then my collection name. So text is equal to text here. So for character or char in text, print char. And then I print each one, even the spaces. The spaces count as characters as well, all the way down. And so that's really how it works when you iterate over strings. And then we've already seen the example here with list with the fruits, of course. But here we're going to iterate through elements of a list. We have some auto brands this time, and we have Chevrolet, Tesla, and Jeep. And we're saying for brand and auto brands. That's a pretty good statement. There's a typo in here, actually. Take a look here. Okay. This loop will not run right now because I don't have the colon at the end of the loop there. So I put the colon there. And I run that, and I get my loop. Again, if you take a look, this is kind of an illustration of how descriptive names can really help you see what's going on. In a more real world example, like the URLs, that would be that, or like, what if you're iterating over credit card numbers, because you're in fintech and you're having to dealing with accounts, and you have to loop over the accounts. I don't know if you'd be looping over those, but you could be. I think was a Mike Zero. You work with fintech, right? Do you still work? Is it Chase you work with? I don't know if he's still here or not. Anyway. So that's how you loop over a list. Tuples are the same exact thing. I don't think I need to illustrate this. We have our coordinates, and we have 3 and 4 coordinate in coordinates. You're going to see that a lot, kind of the singular form of the plural form, because the list is, a bunch of them. So you'll see that as well. Okay. Oh, this is kind of a cool example. So this is a way to use, so we had the key value, right? So we're iterating over that. So let me go ahead and add another code block. Cool. Okay, so here we have a dictionary. We have a dictionary, and we know it's a dictionary because we have the curly brace and the colon. And we're saying that dictionary name is person. And now we're doing a normal for loop. And then we're gonna print some stuff. And if you look, we are printing both things, but iterating only over the keys, because what we're doing is we're referencing back to the main dictionary and then grabbing the value at whatever key we're on. So that's a way you can do that if you want to use a normal for loop to grab both the keys and the values of a dictionary. But I'll let you know right now, this method right here is the preferred method to do it, because then you don't have to type the whole dictionary name to reference the value. So that's 2 different ways to grab the information. Any questions on the data types and looping over them? Yep, and that's right. So Philip just said, hey, we're writing loop, and you know how many times you want to iterate, you should use a for loop. Or if you have if you have to loop over the entire thing, if it's an iterable, it's going to be a list, and you have to go over the entire thing because you use some processing, for loop is fine. But if you don't know, or you're trying to meet a certain condition, then you use a while loop. All right, well, let's take a 10-minute break, and we'll come back and we will go over functions. We'll spend the rest of the lesson on functions. So yeah, let's come back at 7:07. Oh, there we go. Thank you. So, welcome back. I hope everybody had a good break. We're gonna push on through into functions. And just like description says, functions are a fundamental concept in Python, and it allows us to find reusable blocks of code. And that code reuse is a very important concept, and it's a bit hard in the beginning to kind of wrap your mind around. And it's okay if you don't make your code 100% reusable. And it's a skill that's developed over time. But it is, keeping your code dry or, don't repeat yourself is a pretty important concept. It makes the code easier to read. So if you find yourself writing a script and you're doing something over and over again, you're writing out over and over again, it's best to go ahead and pull that logic out and put it into a function. And this lesson will help give you kind of the basic syntax for that. And that's really what we're trying to give to you guys is it's a function, just the syntax for a function, so you understand how to read it, and then you can start experimenting with how to put it together. And so the basic function we have it's also driven by a keyword, which is def. What you're saying is you're defining a function and you're giving it a name. And the name can be any name, but it has to, still follow the rules with Python. And that's with, the camel case lettering, where we have all lowercase separated by an underscore. And then another key part of a function is an opening and closing parentheses. Inside the parentheses, you could have parameters. Or other people call them arguments. They are used inside of the function because you're trying to do something to or with these parameters. And then you have this colon kind of signifying where you're kind of done defining the main part of the function, and then everything else is indented. So with Python, again, those indents matter. So everything under the function will be indented. Oh, I am so sorry. I forgot to stop sharing my screen. Don't be afraid to come off mute and let me know that stuff. Let me see. It's going to be this screen. I am so sorry. Can you see my screen now?
Yes.
Okay, awesome. So everything I just said, I was just highlighting right here in this in the function. So we have the keyword def, and I'm pretty sure some of you had this open to follow along with what I was saying. But let me go ahead and add another code block. Put it in here. Oops. Okay. You see the coloring is a little different because this is a markdown file here, and this is actually Python code, so it looks a little different. And this one, it kind of makes the function definition italics, and then you have your name. And so again, you have with the function, you have your name, and then you have your parentheses, and you have your optional parameters inside. And then underneath it and indented, you have the code that actually runs inside of the function. So in this case, we have the function name, and then it has the parameters. Just like with the loop, these parameters, and you're going to see how this works with a real function here in a minute, but these parameters are really, you're naming them as the function is run. So every time the function runs, whatever you're putting into the function will be renamed to whatever name you put here. And that way you can have reusable code. And so really, let's kind of look at this real example here. This is a pretty standard example. So we have a function called greet. So the name of the function is greet, and it takes a parameter. And the parameter here in my IDE kind of highlights it as orange, and it takes a name in. I don't know what name yet, because really I'm just defining the function to take any name, really. And I'm saying, okay, I want to take a name, and then I want to return. So this is another keyword where I want to return something out of the function. So I have an input, which is the parameter, and then I have my output, which is what the function is going to return. In this case, I have I'm returning a string, and it's going to be an F string, and it's hello, and then I put my variable name in here. So now name comes back out, but it has this string with it. So below here, below the function now, I'm outside of the function. I'm in the code that's in the same indented line as the definition of the function. So this, you can say that this part right here is inside the function. And then all this stuff that's indented on the same line as the definition of the function is outside of the function. And you're going to call a function somewhere outside of a function. So in this case, we're going to assign the call of the greet function as a variable and then print it. So in this case, we're defining a new variable called message, and we're saying, hey, I want to equal to whatever comes out of this greet function when I put the string Alice in there. I want to go ahead then assign that to my message, and then I want to print the message. So in this case, it says, hello, Alice. Or I could run it again with hello, Mike. Or whatever name I put in here. It's going to run and then put that name, once I put it in the function, it's going to put that name in here, and then that's what's going to be the variable. So the variable message is going to equal this, because that's what's being returned from the function as it goes in. Any questions on how that simple function works? Okay. So we can also have functions with multiple parameters. And so we can have this function here, which is a nice, easy one to look at. Okay. Here, I'm defining a function called add, and I have two parameters, A and B. Okay, these aren't really going to be good variable names. I would say let's do number 1 and num2. And then of course I want to return. Now it doesn't know what A is or B, so I gotta change those. Okay. And so I'm saying number 1, number 2, and I want to return number 1 plus number 2. I'm kind of, looking at this, I'm kind of relying on the input to be integers. But I can kind of show you both what happens with strings or anything else. So in this case, I'm returning num1 plus num2, and then I'm assigning the return of this function as the result variable, and I'm printing result. So if I run this, I get 8 printed out. Okay, I can change this to 65 and 87. I run it now, I get 152. So that works. That add function works. Okay. But what if I put a string in here? Like that. If I run that, I'm gonna get an error because I can't concatenate a string and an integer. So I need to either have both strings or both integers. If I run that, then it takes number 1 and just smashes it next to number 2. And this is a string 6587. So that's where you can have as many parameters as you want in a function. Typically, unless it's a special case, you're not going to have like a bunch of, you could, depending on what your program's doing. But typically you're going to try and break down your code to where functions are easy to read and you're not having an exhaustive list of parameters put into a function. You'll break your code down even further. And that way you can have smaller functions doing things. So. Oh yeah, so Kiana says we'd have to convert those strings I had before. I had to convert them to I have to convert it to an integer or something to do the concatenate or to do the adding or concatenating and converting it to a string. Either way, yeah, you can do that. You can do that right there inside the function if you want. You can even add if statements. So you can do kind of like a sanity check on the data coming in, or you can make it to where a person could add something else. So in this case, I have one string and one integer. I know I'm going to get an error with this because I'm trying to add a string and integer, but I can say if num1 or if type, I guess. So if type num1 equals, I think it's going to be, I think it's 7 quotes. I think it's just this. Or let's do that first. So if that num1 equals int num1 1. And then I can also do the same for num2. And I wouldn't have to do it this way. I could do it, I can show you an even faster way, but I just want to kind of illustrate this. So here's num2, num2, 2.
Wouldn't the first one be integer? Oh, I'm string. Oh, it or
Right. So I want to make sure that if it is a string, I want to cast it into an integer. So if I run this, now I get 8 because it did catch it for that one, for the first one, but it didn't run this if statement here for the second one because it was already an integer. So and you could always just, you know, if you know you're gonna get strings and integers, you can always just cast it anyway. So you could do it this way as well. So you don't even have to have the ints, the if statements to convert it. Let's see if that works. Yeah, that works too. So you can just recast if you know it, either one or another will be a string. You can just cast it. You don't have to have an if statement in there. You can just run it anyway. So there's options. Any questions on that so far? So what if I have a decimal? Yeah. So we would have to convert everything to float. So if we have decimals, then we want to make sure we even go to the even more flexible type. So now we're going to have maybe some decimals. We can just cast everything to a float. And it won't matter if it's a singular digit or not. It's just your return is going to be a float now instead of an integer. So you could have integers or string representation of integers. You could also have it like that. And no matter what, it'll run. So that gives you some options as well. All right, this next section here with nested functions, this one's a bit hard to wrap your mind around. I mean, even for me, like when I look at this, I'm like, what is going on here? This one's quite the doozy. So I think I actually, let's see, did I put it up here? No, I didn't. But I did want to illustrate what's going on here, or at least try to anyway. And so when you take a look at this, we have a function, and then inside of that function, we're defining another function. But inside this outer function, we're returning the inner function that we're defining. So we have the outer function, and then inside there, we define an inner function. And inside that, we return our x plus y. I wouldn't worry about understanding what's going on here. There's nothing in the exercises, but this is just showing how you can layer functions inside of other functions. Typically, you're not going to kind of write it this way because you'll typically want to do some other unrelated, function inside of another function. But in this case, we're actually just trying to add 5 to 3. And so if I were to run this, I do get back 8. And how it's working is I'm first defining the function and then returning the inner function. And then I'm making a variable called add 5 here, and I'm defining it to the output of outer function. So, and I'm giving it a parameter of 5. So in the outer function, I'm giving it 5 here, and then it's returning the inner function that's inside of there. So in there, inner function knows what x is because it's inside of the scope of this function. So it's going to put the 5 right there on the x, and then the 3 is going to be called right here. and it's going to be put into this return statement as well. So it's going to be 5 plus 3, and it's going to return out back as result. Really hard to wrap your mind around. This one always throws me for a loop. But I can visualize it with the Python tutor, so you can see it there at least, and see it work step by step. But even then, it's still kind of a bit hard to see. So in this case, I have my outer function and my inner function inside of it. And when I step through this here, I'm going straight down to here. So I'm defining the function. It's going to know what the function is. It's going to go right down here to line 6 and make a variable called add 5. And it's going to then get the output of outer function. So it's going to go into the function, and it's going to then execute returning the inner function. And then result, it's then going to add the other parameter 3 to add 5, which becomes the inner function, if you will, and then return the 3 plus 5 and to give you 8. So again, I wouldn't worry too much about the syntax or wrapping your mind around nested functions, but it's a way that you can do more as the complexity of the problems you're solving as that increases, you may have to find yourself in a situation where you have a function and you realize that you're doing some repeatable steps in that function. You're like, well, I need to extract that code out and actually do another function inside of this function. It happens. So you'll get to that point eventually. Luckily, with the exercises here and with the application requirements, you're not really having to worry about that. You can still separate functions out in your application exam. You have that ability if you're comfortable with doing that, because you will have to do stuff that does repeat. So just keep that in mind. And I would really practice functions. We do have some practice work with functions where you can do that. So again, this is kind of just an example how you can put functions inside of functions that still work. This does also introduce I did mention a bit with this last example, but this does introduce the concept of scope. So variables inside of a function, they are only able to be seen from inside the function. So in this example here, we're defining a variable called x, and that's equal to 10. Inside this function, and what I mean by inside, again, I'm talking about the stuff indented under the function. We can reference x all we want. We can print it. But once we're outside of the function, and we try and call print of x that we defined inside of the function, Python won't know what to do. And so I can show that here. Add another code block. And so here, it's saying there's a name error. There's see how there's a little squiggly underneath the X there? It's not here. There's no squiggly here or here because Python knows what that is. But once you put your print statement out here, it's looking for what X is outside of the function. It has no idea. So we can't see inside of the function and get that X. So if I were to comment this line out, I do get X printed because I'm calling my function. I'm calling my function and I'm defining X here, and then I'm printing it, and you can do that. And this also illustrates another point. When you make functions, you have to call them. And so that's exactly what we're doing here on the same line, is I'm defining the function here, and then I'm calling it. So I need to, basically call this function right here. And if there's no parameters, then I can't have parameters in here because it's going to error out, say, hey, you gave it parameters, but it doesn't expect any. So, in this case, this function has no parameters. And it has no return statement either. So it's not returning anything as well. All it's doing is just printing, which your functions can do. Any questions on the scope?
I'm a little confused under the first example, why you have the inner function, the return inner function. That part's
Right.
kind of throwing me off.
Yeah, like I said, I wouldn't worry too
Okay,
much about this.
okay.
This is just to show, illustrating you can define functions. I really wouldn't worry about it right now.
Okay.
Yeah. Yeah, again, this is just showing a bit of, complexity. Just hit the I believe button right now on that one. So, but for this is a pretty clear-cut example of how a function works and then how scope works. If I were to try to print X right here, I can't do that because Python outside of the function has no idea what X is. I never defined it above the function or anything. So
I'm slightly hazy on the return versus print, and I know you mentioned it in the beginning of the class, but you just referenced it again. Could you just go? Oh, okay.
Yep, about to cover it. Yep, that's what I was about to transition into. So yeah, so the return statement. So Python functions and functions in general for any language really, they typically do return something. So you're going to want to get a result of a function, especially if you're defining a variable with whatever you're returning from a function. So if you're calling a function as a, when you're assigning a function call as a variable name, which you saw up here, we did it a couple times, like here, this message, we're defining a variable based on whatever this function returns. So it's to specify a value that the function should return. But again, it's optional. Sometimes you just want functions to print something. Sometimes you want functions just to do something else and not return anything, and that's fine. But a lot of times you're going to have a return statement. In this example here, we have, we're doing a multiplication now. We're returning A times B versus, A plus B when we did add. So we could almost take like functions and make like a calculator like we did yesterday with functions. We could do that if we wanted to. We can just define a bunch of functions, and then we have our input parameters, and we just need to read a string and see what symbol is in there. And then once we know that, we know which function to call on the two variables, and we just cast them, change them out, turn them into floats, and we throw them into the function that returns whatever the result is. And we can make a calculator with 4 different functions for each calculation type. So and that's probably a good exercise for you to figure out on your own. On your own time, I would say, hey, I want to see if I can make a little basic calculator with 4 different functions. That'd be something good that you could probably try on your own. So that's really what the return statement is. Return won't necessarily print something. So sometimes you'll have a return to a function, and like when you try it out on the Python tutor, for example, and you have a return, it'll show you what it's returning. But in Python, if you're not printing, if you're not actually saying print, it may not print anything to the console. Even though your function worked and it returned something and everything else, you may not get a friendly print statement. Sometimes you have to kind of print the result or assign it to a variable, then you can print it to see the return. So this next section here is kind of perfectly placed, actually, is when to use print statements. And that's exactly this scope thing I'm talking about with the X here. Yeah, I run the print function here. The Python code ran here and it printed it as it knew what X was, but it still finished the script. So sometimes, if you're writing functions that are doing a bit more complicated work, so let's say your function is, 30 lines of code long and it's doing some other stuff inside of it, and you need to kind of check the status of, what's happening inside of your function, you'll just throw some print statements in there. So when you're testing code, you're running it locally in your machine, you can then kind of evaluate as you're writing the function, what is it doing here? That's a typical development task. I do it all the time. I throw print statements and they're like no one's business. And And then I get dinged whenever I'm putting my code up to be merged. And one of my, developer peers is like, you have like 5 print statements, get rid of. And it's like one of the things, you have to remove your print statements whenever you're done. And you actually have, code that's operational, you're pushing into the code base. So, so you use them for troubleshooting, you use them for, diagnosing something that you're working with. In this example here, we have complex calculation, and then result equals X times Y. You want to go ahead and throw your print statement here to see what it looks like before you return it. You may have some other steps, like now that you have, X times Y, then you want to square the result and then do something else. And you can throw print statements anywhere to kind of see the progress. So those functions, the print statement is perfect for that use case, so you can see what's going on in the console. So yeah, so functions themselves, they are super powerful for organizing your code. You're going to find that when you start looking at more complex code, let's say you've already went out to GitHub and saw some public repos and you saw some code bases, and you see like lots of files on the side, and you see their different names, and then you're seeing that the code is kind of going this way, and all of a sudden it jumps to another file and runs, and jumps to this file and runs. That's exactly what it's doing, and it's following functions as they're being defined and called. So it doesn't necessarily run. You'll have one file that kind of runs linearly, but it's calling a bunch of functions in other files, and your code is traversing through several different files as it's being called. Luckily for this course, we're keeping everything on the same sheet of music, so we can see it all, and as we learn this foundational steps of Python code and dealing with integers and strings and floats and lists and tuples, we're going to take a deep dive in those as well. So today, though, we talked about loops. We talked about all the different types of loops, the standard for something in an iterable loop. Then we have our our range. We can use the range function to give us if we want to run a loop a certain amount of times, not necessarily based on whatever we're iterating over, just kind of we just want to iterate over a certain number of times. And then we have our dictionaries. We can use the key value for key and value in dictionary.items. And we have enumerate, which is really powerful. We want to find the index and reference that in our code, the index and the actual iterable itself, the item that we're looking at. It kind of pairs them together so we can use that code inside the for loop and do stuff. So then we went into functions. We talked about how we can use them, the different structure of functions, the keywords, and hopefully you got some pretty good understanding of how they work. Let me refresh this. There they are. So we have some assignments here at the bottom on section 5. We have 4 of them. And the reason we have 4 of them is because we have a pretty long break between this class and the next one, because of course Monday is Christmas. So we will be getting back on Wednesday, but we can take this time to kind of go over the assignments and take a look. And then once we kind of go over, at least seeing the assignments, we can then break and start doing them. We can do some, breakout sessions or whatever at that point. So let me go ahead and look at the first one. Oop, I meant to actually do a new window because let's do a new window. Yep, I know. Yeah, the link to Camel Case actually goes to the FizzBuzz again. But I have the link. I can share it. So this first exercise here, it's just kind of giving you some practice to iterate through different data types. Just like in the previous exercises, if you want to start with part 1, you can just highlight everything. So of course you'll need to fork this over. So when you first come in here, you'll need to fork this to your profile. So using the fork right here. So you'll fork it, and then you can go ahead and hit, Command or Control / to comment everything else out other than what you want to work with, and then you'll start working with it. And so in this part right here where it says code goes in here, this is where you'll type your code. So it says use a for loop to iterate through the list and print each element. So the kind of the first example we showed in our loop right here. So right here. So with the URLs. And then it goes over looping through a tuple, a string, and then using range to go through there. You'll find that you may have to play with some of the values in range. Just remember with range, it's the start, which is inclusive, and it defaults to 0. You can make it whatever number you want. And then your stop does not include whatever number you put in there. So if you're trying to loop, the numbers 5 through 10, you'll need to start with 5 and actually end with 11, because up to but not including. So it's not inclusive of that number. So you have to kind of think about that if you're trying to get a certain number in there. So we're using range and then looping over dictionaries, using a while loop. Also in the REPL, if you mess up your while loop and it runs continuously, there's a stop button at the top that you can use, and that will get you out of there if you accidentally use a while loop. So in the case, like if you have the loop running and you run it this way, you can hit stop too. It'll show up as a stop. While it's running, it's going to show up as a stop button that you can stop it. Got a question here from Seth that says, is there a simple way to pass an operator through a function? I guess, what do you mean by that? Oh, okay. So you're saying like a plus minus. Okay. Yeah, so just like the calculator we did yesterday, let's say you have you pass everything as one string, you can then search for whatever symbol you need, and then do your conditional logic there. So then you can find whatever string, like whatever value it is. And then you can just use a conditional, like an if else statement, to find whichever one is, and go to different branches of code, like calling different functions to do the calculator. Part 7 is pretty cool. It has like a nested loop. So just like with regular loops, just like the functions, and you have nested functions, you can have nested loops. And that actually ties into a later concept where we talk about like the computational load and how the complexity value of what you're doing. When you start adding loops inside of loops, you make your loops logarithmically longer. So you got to be careful when you add several loops inside of other loops. But there is a good exercise at the bottom called multiplication table that shows that concept. Is pretty cool. Let's go to the next one, and I will give you the link to the last one as well when we get there. Okay, so yeah, this one here, you just want to write a function that takes an integer as seconds and then prints how many seconds there are until liftoff. And so you'll want to put some logic in here that will do some evaluation of your input parameter to give you the correct output. And then you'll call your function here. That's what's happening. We're defining the function here. We're just putting a pass statement for now because we don't have any logic in there, because that's what you're supposed to do to solve it. And then we're calling it, and we're using the 5 as the initial, but you can use any number there if you want. So you can change that if you want to. Oh, dang it. I forgot to open a new window. Open a new window. Daniel, are you using are you on the like web version, or did you like this QuickPass, like this same address right here in loops and functions? Did you open it earlier today? Okay, so yeah, one of the other instructors added it this afternoon, so it's probably after you opened it. Just hit refresh and you'll see it at the bottom.
For the first one, why is it under the code goes in here after you've solved the problem? Is there a print and then a string, but then when you print it, nothing appears?
So that's a new line character. It's making it to where it organizes your output. So just leave it where it is. Yeah, it's just that's called a new line character. So that backslash inside of a string is called an escape character. And then it allows you to put one character after that to do something versus print something out. So in that case, that's a new line character. So if you were to print, a bunch of text and put that slash in, it'll put it on a new line in the console. And so all that does is that makes, whenever you start uncommenting the different parts out, it gives you a break between each one so you can see the results of each problem.
Thank you.
You're welcome. So this next assignment, FizzBuzz, this one's a great, I love this exercise. And so, I mean, it's true. Like you could give this to somebody who maybe was like self-taught and just didn't see this. I mean, everyone sees this problem when they're learning how to code, but some people don't. And it's something that can actually filter out candidates. Like if they're saying, yeah, I'm a expert in Python, I love, I develop these websites, and you give them this FizzBuzz problem and they can't figure it out. That's a bit of a red flag. Luckily, you're getting exposure to it right away, but this one's a great exercise in logic. And the way this one's structured is a bit different than what I did. I kind of did a simpler implementation, but this one here actually wants you to create a dictionary with all the entries. So you'll need to create a dictionary with 100 keys, and the corresponding value is going to be a number or fizz or buzz or FizzBuzz. And so so this is what like your result needs to look like, because what it's doing is going to give you a true or false whether you got it right. This is the function that is being called, this FizzBuzz 100. So it's going to be FizzBuzz and the number is going to be 100. So you have to figure out what logic is underneath that function to create a dictionary that has all of these correct values. So the key value pairs. So 1 is going to equal to 1. So to step back a little bit, if you've never seen this before, the whole premise of the problem is I'm going to give you an iterable of 100 numbers. For every number divisible by 3, I want you to replace that number with fizz. for every number divisible by 5, I want you to replace that with buzz. And if it's divisible by both 3 and 5, then I want you to replace it with fizzbuzz. And basically, you're going to write a loop that's going to do that. So it's a pretty fun exercise to work through. And it's, you know, it's perfect for folks just learning how to manipulate data types. I don't anticipate all of you finishing this one, but I'll save this one for our next meeting. We can go over this one and kind of see how it works. And then the camel case one, let me open this real quick. It's going to open to the fizzbuzz, but I'll change it. So the URL. That's gonna be it. I'll put this in the chat so you guys can go to it. There we go. I'll put it into the Slack channel too. Actually, I can probably just edit the link. I think I have the ability to do that too, I guess. So anyway, with this one here, this talks about the Python, which uses snake case. With JavaScript and other languages like Java, they use camel case. So if you take a look at the examples here, this is camel case. So it has basically starts with lowercase for the first word, but every other word, there's no space, but the first letter is capitalized. And in Python, that's how a variable will be named. And so what you're supposed to do is write a function that takes a camel case argument and then converts the sentence to the snake case convention. So when you get this, your output is this. And so you have to think about how you're going to manipulate strings, how you're going to iterate, because you're going to have to take a look at the whole string and look at each character and determine, okay, what am I going to do with this character? How am I going to break this problem down? So that's a really good one too. This one really hits on some of the concepts we've learned, but we haven't really taken a big deep dive into strings, but I have taught you all the stuff you would need to finish this one. So that's the end of the lesson. We just came just under 2 hours with this one. So are there any questions right now? I figure we're probably going to go ahead and go on a break, and then we'll return and we can work on these exercises. We can ask questions. Yeah, woo, it is quite a bit. And you have plenty of time over the holiday to kind of just take a look at some of the stuff. This stuff's for you. So I recommend really diving in, and if you have any questions, the Slack channel's open. I'll be looking at Slack, not all the time. I'm not gonna have my eyes peeled in there, but I get alerts and I'll help out. So will our TAs. They'll chime in, and if you see a question from a fellow student in the room and you want to answer it, go ahead and give it a shot. Even if you're wrong or if you're not quite right, at least you can work together to find a solution, and we'll be happy to chime in and give you guys some pointers so you can figure this out, because the goal is for you guys to learn how to deal with these basic data types and get this foundational knowledge, so you can pass the entrance evaluation and the live coding assessment to join Whiskey Platoon. That's the whole point of QuickPass, is to give you guys this quick crash course and get you ready to go through the real boot camp, because it gets way more complicated than this for sure. But this is a good foundation for that coursework. So with that, I'm going to stop the recording. Let's see where my recording is at. Let's stop share first.